Welcome to Summarize Science, where we break down the latest breakthroughs in technology. Today, we are looking at a study from the University of Edinburgh about why vision language models struggle to recognize human emotions. Even though AI can describe a landscape or identify a car, it often fails at understanding how a person is feeling in a video. The researchers point out that recognizing emotions requires tracking subtle, dynamic patterns that unfold over very short periods. Humans are naturally great at picking up on micro-expressions that last only a fraction of a second, but AI often misses these cues entirely. They identified two root causes for this failure: head class bias and weak temporal modeling. The first problem is that the data used to train AI is long-tailed, meaning it has thousands of examples of common expressions, but very few of rare ones. Using Google Books Ngram data as a proxy, the researchers showed that the frequency of an emotion in literature correlates with how well an AI recognizes it. Because of this, models like Gemini or Qwen tend to collapse rare emotions into common categories, like misclassifying contempt as neutral. Essentially, the AI defaults to the most frequent label it has seen, rather than learning the unique characteristics of complex feelings. The second major issue is how AI watches video. It often treats it as a bag of frames rather than a continuous sequence. When the researchers shuffled the order of frames in a video, the AI's accuracy barely changed, which is a big red flag. This suggests that the models aren't really reasoning about how an expression evolves over time. You might think giving the AI more frames would help, but it actually has the opposite effect. The researchers found a quasi-bell-shaped relationship where performance peaks at about 5 frames per second and then drops significantly. This attentional dilution happens because the AI gets overwhelmed by redundant data and loses track of the most important moments. To solve these problems, they proposed a new strategy called Multi-Stage Context Enrichment, or MSC. Instead of just feeding the AI a bunch of raw images, this system uses a two-step process to bridge the temporal gap. One AI model looks at the in-between frames and creates a detailed text summary of the facial movements it sees. This text summary acts as a temporal bridge that allows the final model to understand the evolution of an expression without being overwhelmed by visual tokens. The AI reads these descriptions alongside key images, helping it spot those fleeting micro-expressions it used to miss. The researchers provided a specific prompt structure to help the model synthesize these images and text summaries into a final emotion label. The results showed a consistent improvement across several different AI architectures when using this enrichment strategy. By translating motion into language, the models were finally able to see the emotional trajectory they were previously blind to. To recap, this paper proves that AI's emotional struggle is both a data problem and an architectural problem. The training data is biased toward common emotions, and the way AI processes video makes it miss critical, fast-moving signals. By using text to summarize motion, the researchers found a way to help AI feel the flow of human interaction more accurately. In the future, this could lead to more empathetic AI assistants and better mental health screening tools that can truly read between the lines. Thank you for watching Summarize Science.